You can step outside on a clear night and see 5 planets shining with your own eyes: Mercury, Venus, Mars, Jupiter, and Saturn. Each one glows like a tiny lantern hung in the darkness. But if you keep looking farther, beyond Saturn's pale rings and the faint blue of Uranus, you'll reach a point where your eyes fail you. Out there, nearly 4.5 billion kilometers from the Sun, lies a world so distant, so dim, that no human being ever truly saw it, until mathematics pointed the way. That world is Neptune, the farthest known planet of our solar system. Averaging 30 times farther from the Sun than Earth, it completes a single orbit every 165 years. Sunlight. There is a whisper, just 1/10,000th of what we feel on Earth. If you could stand on one of its frozen moons and look up, Neptune would appear as a faint blue ghost wrapped in storms, a planet colder than any place we've ever visited. And yet, this quiet-looking giant has a strange claim to fame. It's the only planet ever discovered before it was seen. A world predicted entirely by math. For more than a century, Neptune has remained a scientific riddle at the edge of light, a planet that defies what we expect from a frozen sphere so far from the Sun. Now, with new eyes like the James Webb Space Telescope peering into its haze, Neptune is once again revealing secrets that challenge everything we thought we knew. But before we can understand what Webb has shown us, we have to go back to the moment when Neptune first appeared, not through a telescope, but through the mind of a mathematician. In the early 1800s, astronomers thought they had the solar system all figured out. Uranus, discovered only a few decades earlier, neatly followed Newton's laws. But over time, something didn't add up. Uranus's orbit kept drifting, just a little off, but consistently wrong. It was as if some unseen hand were tugging at it, pulling it off course. Many scientists blamed the data. Maybe their telescopes were misaligned, or maybe their measurements were off by a fraction of a degree. But one man refused to accept that answer. His name was Urbain Le Verrier, a mathematician from France who believed the numbers themselves were telling a story. He analyzed the anomalies in Uranus's orbit with relentless precision, translating tiny discrepancies into gravitational clues. Piece by piece, he calculated where another unknown planet must be hiding, one massive enough to disturb Uranus, yet distant enough to remain unseen. When he finished, he sent his predicted coordinates to Johann Galle, an astronomer in Berlin. On the night of September 23, 1846, Galle pointed his telescope exactly where Le Verrier's math had told him to look. And there it was, a faint blue disk right on target. Neptune had been found, not by chance, not by guesswork, but by pure calculation. It was a triumph of human intellect, a planet discovered through logic alone. No one had ever done that before, and no one has done it since. For a brief moment, the world celebrated. But after the excitement faded, Neptune slipped quietly back into the darkness. It had been found, yes, but not yet understood. More than a century after Neptune's discovery, the planet remained nothing more than a blurry dot in every telescope. Then, in 1989, a visitor finally arrived, not from Berlin or Paris, but from Earth itself. Voyager 2, a robotic spacecraft launched 12 years earlier, had already flown past Jupiter, Saturn, and Uranus. Neptune was its last stop before leaving the solar system forever. The spacecraft didn't orbit or slow down. It simply raced past the planet at 90,000 kilometers per hour. A brief encounter after a 12-year journey. But in that fleeting moment, Voyager gave us nearly everything we know about Neptune today. Its cameras revealed a world far more active than anyone expected. Scientists thought Neptune would be calm and frozen, a quiet giant drifting through the dark. Instead, they saw roaring winds, swirling storms, and an atmosphere alive with motion. One of those tempests became famous, the Great Dark Spot, a massive storm the size of Earth spinning backward against the planet's rotation. And those winds? They were the fastest ever recorded in the solar system, over 2,000 kilometers per hour, faster than the speed of sound on Earth. How could a planet so far from the Sun, receiving less than 1/10,000th of Earth's sunlight, have so much energy in its atmosphere? It didn't make sense. Something deep inside Neptune was driving that power. Voyager also spotted faint rings, uneven and patchy, and 6 new moons orbiting close to the planet. It even gave us our first clear view of Triton, Neptune's largest moon, a frozen world that orbits backward. Then, just like that, Voyager was gone, vanishing into the void. One flyby, one glimpse, and an ocean of mysteries left behind. The more scientists studied Voyager's data, the stranger Neptune became. Everything about it seemed impossible. The planet sits in a region of the solar system where sunlight is so faint it barely warms space at all. Yet Neptune radiates more than twice the energy it receives from the sun. Somewhere beneath its blue clouds, something is burning, not with fire, but with heat born deep within. Uranus, Neptune's near twin in size and composition, barely emits any internal energy. But Neptune glows with it. Why? One theory suggests that its violent birth trapped enormous amounts of heat inside, heat that still escapes slowly after billions of years. Another proposes something even more exotic. Inside Neptune's immense pressure, methane molecules could break apart, forming diamond rain that falls through a dark ocean of carbon, releasing energy as it sinks. Above that deep, mysterious interior, Neptune's atmosphere is a stormy sea of contrasts. Its upper clouds are made of frozen methane crystals, floating above turbulent layers that churn like boiling water. Winds circle the planet faster than sound. Storms rise and vanish within days, twisting into spirals larger than continents. Even Neptune's magnetic field refuses to behave. It's tilted nearly 47 degrees and offset far from the planet's center, as if the entire magnetic core were misplaced. No model fully explains why. All of this paints a picture of a planet that shouldn't be this alive, a frozen world acting like a furnace. Something is feeding its energy, something we can't yet see. And with Voyager gone, all we could do was watch from afar, waiting for our next chance to look closer. After Voyager 2's brief encounter, Neptune faded back into darkness. For decades, no spacecraft would visit again. The only way to study it was from across billions of kilometers, through the patient eyes of telescopes. And no eye was more watchful than the Hubble Space Telescope. Launched in 1990, Hubble became Neptune's silent guardian. Its ultraviolet and visible cameras pierced the haze, revealing that the planet was anything but still. Storms kept forming, moving and disappearing. In 1994, Hubble spotted a new dark vortex, proof that the Great Dark Spot wasn't a one-time event. More followed in 2015, 2018, and 2020, each storm behaving unpredictably, as if Neptune's atmosphere were rewriting its own rules. Hubble also discovered something remarkable: a tiny new moon, Hippocamp, only 34 kilometers wide, orbiting just outside the rings. It was so small that Voyager had missed it entirely. The discovery hinted that Neptune's system still held secrets, even after decades of observation. But the strangest finding wasn't about storms or moons, it was about temperature. Using infrared data over nearly 20 years, scientists found that Neptune's stratosphere was cooling, dropping by about 8 degrees Celsius between 2003 and 2018. Then, unexpectedly, the planet's south pole began to warm up. The shift was too fast to be explained by Neptune's slow seasons. Something deeper was changing, perhaps from within. Hubble didn't solve Neptune's mysteries. It multiplied them, but it also prepared the stage for what came next, a new telescope that would see not just through clouds, but through heat itself. A telescope powerful enough to look into Neptune's invisible world. When the James Webb Space Telescope finally turned its golden mirrors toward Neptune in 2022, no one knew what to expect. For more than 30 years, we had only seen the planet through Hubble's limited range of light. Webb, however, could see what no human eye ever could, the glow of heat and chemistry beyond the visible spectrum. What it captured was stunning. Gone was the deep ocean blue world familiar from textbooks. In Webb's infrared view, Neptune appeared almost translucent, a ghostly white sphere surrounded by sharply defined rings and bright icy clouds hovering high in its atmosphere. For the first time since Voyager 2, the planet's rings were seen clearly again, shimmering like a halo of cosmic dust. But the real surprise came 3 years later. In 2025, Webb's new observations revealed Neptune glowing, not from sunlight, but from within. Patches of infrared light flared across the planet at mid-latitudes, where no one expected activity. These were auroras, massive curtains of charged particles slamming into the atmosphere and lighting it up from the inside out. Normally, auroras form near a planet's poles, but Neptune's magnetic field is tilted almost 47 degrees off its axis, twisting and warping space around it. The result? Auroral bands that stretch far beyond the poles, wrapping the planet in an unpredictable glow. Webb's instruments detected strong signals of trihydrogen cation, a molecule that forms when energetic particles hit hydrogen, confirmation that the light wasn't just reflection, but real atmospheric reaction. For the first time, we were watching Neptune's energy flow in real time. Heat, magnetism, and chemistry dancing together on a world we had barely begun to understand. We've sent orbiters to Jupiter and Saturn. We've walked on Mars, flown by Pluto, and even dropped a probe onto Titan's orange haze. But Neptune, the farthest, coldest, and most mysterious of them all, has been waiting alone since 1989. One flyby, one glimpse, then silence. And yet, this distant planet may hold the key to understanding the most common type of world in our galaxy. Across the Milky Way, thousands of exoplanets we've discovered are Neptune-sized, icy giants cloaked in clouds and storms. If we can't explain the one in our own solar system, how can we hope to understand all the others? That's why scientists keep calling for a new mission. A dedicated orbiter to study Neptune's rings, storms, and magnetic field up close, maybe even a probe to plunge through its clouds. NASA's proposed Neptune Odyssey remains only an idea, while China has hinted at a 2033 mission. Whoever goes first will uncover a world that's been whispering to us for nearly 2 centuries. Neptune is not just another planet. It's a reminder that discovery isn't the end of curiosity. It's the beginning. The question isn't whether there's more to learn. It's what we're still waiting for.